So I'm going to do this myself. We just get this. It takes a couple seconds. Pull this out and launch the engine. All right. Is everyone here? So what we're going to do is create a new project. We'll call it Game Dev Workshop. All the default settings are good. Just remember where you make this and hit create. So this is the basic UI of Godot. We have 5 main panels here. This is the scene viewer, where you can essentially see it's a visual representation of everything in your game, right? You can use right click to look around, middle click to rotate, um, left click to select things, and you should also be able to, yeah, when you're holding right click, you can use WASD to look around. Do you need help downloading the engine? Do you know where to get it? You could try WH221. Depending on how many people are in there, there might be a computer that's not using a mouse. So this is the scene viewer, right? Just lets you see what's in here, lets you visually edit things. This window over here is called the node tree. This is essentially all the things, and I'm using that word kind of roughly here, but all the stuff in your scene will be visible in here as sort of a hierarchy of objects related to other objects. It's not going to make too much sense now, but as we go through the workshop, it's going to be a lot easier. Down here is your file system. This is just all the files in your project. And then over here is the properties editor. Basically, if you have a node selected on this side, you're going to be able to see the properties and edit here. So the first thing we're going to do is get the pre-made assets for this. And that should be at, so if you go here, open this, we have the, I'm going to change the scene here. There we go. We have a write-up for both of the workshops. This one is not finished yet, but it has enough content for the actual live presentation. So we're going to go to making a game. We're going to click this link, and we're going to download the assets. Just take these, extract them. And I'll wait a minute for everyone to get to this point. We almost there? Do you have the engine installed already, or do you need to get it? All right. So what we did is we went to this link. This is the write-up for the workshop. Went to section 10 and then clicked here. to get to the assets. And then you just download this, extract the zip, and you get these files. All right, is everyone ready? Okay, so what we'll do is take these 4 files and drag them into this file system window. And the engine generated a lot of stuff here, so let's go through this. This is not part of what we imported. This is a default icon that's included with every project. We have a couple of models here called GLTF files. That this is the model format that Godot best supports. So if you're in the game jam and you're 3D modeling, this is going to be what you want to export to. And it breaks it down into all the different parts of the model. And in the case of the player character, we also have an animation player with all the animations. I'm not sure why the legs are all the way down here with walk. This does not appear in game. This is only in the preview. So that's a bug with the engine, but this looks normal in the game. So one thing you might notice, and it's kind of hard to see if you're not familiar with the model, but we have some weird artifacting. Like this border here is 2 pixels wide. So is this one. Or in the motor oil can, some of the boundaries are not quite even. The reason that's happening is because when it extracts these into textures, Godot doesn't know that this is essentially pixel art. So it's going to try and compress the texture because for most textures, a couple different pixels doesn't really make a difference. But for this one, it is very apparent. So what we do is we will select the texture, go up to import, and then change the mode from VRAM compressed to lossless and re-import. And we're going to do that with all the textures. And that's already lossless. All right. So now if we go back to the model, the borders look a little cleaner. And again, this is not something you'll really notice unless you've been working with the models. But when you make your own for the game jam and the textures look weird, make sure to check the import mode for that. So you're going to choose the texture file, and the import tab is right here. Does everyone have those textures set? All right. So now we are going to make a scene. So the first thing we're going to do is go back to the scene tab and hit 3D scene. And now we have UI scaling.
Yes. You go to like.
Probably won't. I'm pretty sure it's in editor settings. That's better. All right. So we have all our assets with the right import mode. We're going to click 3D scene to create our first scene. And it has this thing called node 3D just popped up. This is what's called a node that is essentially a single component in your game. And this is a special node because it's called the root node. Every single thing in your scene extends from it. So what we can do to show that is if we right click it, we can add a child node. And we're going to add a CSG box 3D. And now this little line tells us that this box is a child of this parent node. So if we, for example, move the box around, the node is still at the center. But if we move the parent node, the box moves with it. That's the basic system of how nodes work in Godot. Anything, if a parent moves, all the children will move with it. If a child moves, it will not move the parent. So what we can do is use these orange handles to resize the box. But before we do that, I'm going to turn on snap with this magnet and 3 dots. And that will let us click it in increments. And in the bottom left, we can see the size of the box. I'm just going to make it 5 over here, 5 over here. And then you can hold Alt while dragging one of these to extend the other side the same amount. So a CSG box specifically is a pretty useful kind of node because it will have a mesh that renders and it can have collision all in one node, whereas usually you'd have that in separate nodes. This is useful for a game jam where you want to prototype things quickly. You probably don't want to use this for like a AAA game only because if you have a lot of these, it's going to be not very good for performance. So keep that in mind, but great for game jams. What we're going to do is right now it's just a plain white box. We're going to add a material to it. By the way, I'm just going to keep going. Let me know if you need some more time or if you need me to pause. So we're going to drag the tile.png up here into the material slot, and it's going to generate a material. Notice, remember, the tile here is just like a rectangle with a little border. What the CSG box did is it took the texture and stretched it out across its vertices. Even on this side, it squashed it. We don't want that to look like that because it doesn't look good. So what we're going to do is make it tile instead. We're going to select that, click on the material, and we're going to change 2 things. We're going to go to UV1 and enable triplanar. And then we are going to we're going to go under sampling and change the filter to nearest. And I want to zoom in to show the difference. This is what it was originally. Oh yeah, this is what it was originally. This is what it looks like after we change it. But down here, this still looks off because the offset of the texture is not lined up with the platform. All we have to do for that is change the offset here to 0.5. And now that shifts that texture down vertically. And the final thing we want to do also is scroll down. This is going to be outside of the texture, and we're just going to enable use collision. That way our player can stand on it. So UV1, we're not going to touch UV2. UV1, we're going to enable triplanar. Sampling, we're going to change the filter to nearest. And then I'm going to close out of the material. And down here, I'm going to enable use collision. So back on track, we have our platform, right? It has collision. It has the tile texture. What we're going to do also is we're going to add another child node. It's going to be a node 3D. I'm just going to call it, I'll call it map. And we're going to drag, oh, I renamed the box. We're going to call it map and reparent the box under it. So another thing nodes can be used for are kind of like folders for your scene for organizational reasons. So if we have a bunch of CSG boxes in our scene, we don't want to be scrolling up and down through this every time we want to access something. So we could just collapse this and know that all of our terrain exists in this node. So for example, if you control D on this, it'll make a second box. We could bring it in, move it up, and now we have a wall, right? And all of it exists under the map node. So we're also going to, another thing we're going to do, rename this to world. Hit Control S to save, and we're just going to call it world.tscn, and that's going to save right down here because scenes need to be saved as files to actually be permanent in your project. So with that, I just want to make sure I am coming across over the overhead speakers, right? All right, just because we're recording a Zoom meeting and it's using this microphone. All right. We have that. Now what we're going to do is create a player. And, or actually before that, I'm going to take this, move it, let's turn snapping on. Why is that not? That doesn't matter. What we're going to do is under world, we're going to add a new node. We're going to make a camera 3D. And this is going to be how the player actually sees the world. So right now with this minimal setup, we can actually hit run. We're going to select the current scene, and we see that it looks super atrocious, very ugly. The reason for that is because we have no skybox and no lighting in our scene. So the shader doesn't know what to do with the visual information. Godot has really nice defaults to set that up. All you have to do is hit these three dots up here, hit add sun to scene, go again, add environment to scene, and it just adds these two nodes up here. You run it again, and now you can actually see the scene. You ready to move on? All right. So now what we're going to do is make a few more nodes, and I'm going to go through this pretty quickly. We're going to make a character body 3D. We are going to make, under it, we are going to take our model and we are going to drag it onto this node that will import the model and make it a child of this node. We are going to add another child node. We're going to make a collision shape 3D. And then we're going to make a spring arm 3D. And under that, we are going to put the camera under it. So the whole character should look like this. Sure. So we make a character body 3D. And also this is only showing up here because I already selected these. You're going to have to search them up if you're getting them for the first time. A character body 3D. Under that, we are going to drag the model onto it. That will put it in the scene and that will make it, drag it onto it. And that'll make it a child of that node. Add another one, we are going to make a collision shape 3D. Then a spring arm 3D. So we have the collision shape. We're going to add a spring arm. And under the spring arm, we are going to put, I deleted it, but you would have a camera up here and you would reparent the camera under that. So everyone have those notes? Sure. All right, I'm just gonna continue on. So we're also gonna rename a few of these things. We're gonna call this the player. And I just did that by double clicking. You can also right click and hit rename, or you can hit F2. I'm gonna rename this to Juro. And I'm gonna rename this to camera arm. So you'll notice we have well, first I should explain. So the character body 3D is essentially a physics object where you control the velocity each frame. This is what you would want to use for a player character or an enemy that has some specific movement, because most good character controllers in video games don't follow the laws of physics. You want to prioritize it feeling fun over actually being realistic. A lot of other things, projectiles, static terrain, it makes sense for that to follow physics because that would make sense to the player as they're interacting with the environment. But for this, we're going to do a couple things that you just wouldn't be able to do in real life. So that's what the character body is. Under here, we have the model that we imported from the file system. Under that, we have a collision shape that will define the shape to the physics engine of how this player interacts. We're going to have we have a spring arm that I will explain later, and connected to that is the camera. So under the collision shape 3D, we're going to click on shape, new box shape 3D, and I'm going to take the whole player. Also, when you're selecting the player, if you just click on the model here, it's going to select the model. And if you move that, it's not going to move the rest of the player. So when you select the player, make sure to actually click on the player node to get the whole thing. We're going to move it up. And I'm going to take the collision shape. Going to turn off snap. And we can use this, I'm pretty sure this is called a gimbal. And if you double click one of these, or yeah, you can single click one of the nodes, and it gives you kind of an orthographic view of the scene. So that can be used to line up the bounds of the collision box with the model. So I'm just going to bring this up here, line it up here. Doesn't have to be perfect. Include the arms. And that's our collision. And we also have to set some things on the spring arm, or yeah, the camera arm. We're gonna select a ray separation shape, or a separation ray shape. And we're gonna change the spring length to 3. So right now, even though we added a couple more nodes, if we run the game, you'll notice not much happened other than we now have a player here. But something that did happen was the camera, notice, is right here beneath the legs of the player. This purple thing represents the camera. But when we run it, it's all the way back behind the player. That's happening because the spring arm as a physics object is pushing it back. So if we set this to 4, for example, it's now going to be even further back. 3 I found is the sweet spot. So now we're going to add some custom behavior to this. The first thing we're going to do is change the camera arm. We're going to right click it, attach scripts. All the default settings are good, and hit create. So this has literally one line, extend spring arm 3D. What this basically says is this script is meant to be attached to a node of type spring arm 3D. If you've taken a Java course, think of inheritance. This script extends off of spring arm 3D. Going back to the workshop here, we're going to go to 10.2, and this is the script we're going to use for the camera arm. And I'll break down what each part of this does. And feel free to ask questions about this too, because this is the main part of the project. Let's see. Can I shrink this a little bit? All right, this is the size we'll have to deal with, but we have a few constants defined at the top of the script just for if we want to edit these numbers, these are easy places to access them. We're going to have the mouse sensitivity for looking around. This, by the way, this script controls your looking around with the mouse. We're going to have the zoom speed because we're going to be able to zoom in and out of the player, and we're going to have minimum and maximum bounds for that. So we have a couple functions to find here. I'll also mention, if you're familiar with Python, this is a very similar language called GD script. There are a couple things different, like you use func instead of def, you specify types, things like that, but it's generally quite similar. So we have this function called ready, and this is what's called a callback function. Basically, instead of defining it yourself and calling it yourself, if you define it and use the correct name and parameters, it will link to an internal function in Godot that will be called for you. So in the case of the ready function, Godot will call it when your node has fully loaded into the scene and is ready to initialize, and it gets called once. So this is where you're going to want to do your setup work. In this case, the only thing we're doing is we are setting the mouse to be captured within the window. That means you're not going to be able to see the mouse and you can't move it outside of the window. This is useful for FPS games, third-person games, something where you want your mouse, looking around, and you don't want to be able to actually see the mouse and have it move outside of the window. Then we have our input callback that takes an event of type input event, and this will get called by Godot anytime there's a user input. I forgot to do this. We need to make an input map for the game. So we're going to go to project settings, input map. And the way we do this is we'll say, we make the name of an action. So we'll say walk forward. Add that. We'll have the action here. We're going to hit this plus sign and we're going to add a binding to it. So you hit the key you want, it'll show up and you hit OK. And now walk forward is bound to W. And the complete inputs we want here are these. I'm also going to make these in the engine. And when we're making the zoom actions, notice here that these are connected to mouse wheel up and mouse wheel down. If we try and add an action and we scroll the mouse wheel, nothing's going to happen. That's because by default, this is only going to listen to keyboard events. Like, for example, if you chose your key and then hit OK, if it listened to mouse events, it would just register the left click from OK instead of the actual key you wanted. But if you want to capture mouse events, you can put your mouse on top of this text box and it will listen to it. So in this case, zoom in is going to be mouse wheel up and zoom out. Oh, that's not right. Mouse wheel down. Is anyone still working on putting these in? All right. So now that we have that, we can return back to the script. So input event can be of different subtypes. It could be of a mouse motion type, which means anytime the engine captures a mouse motion, it's going to give an event of this type. So we're going to match it against this type. Think is here is similar to the instance of operator in Java, if you remember learning that in 260. And what we're going to do is we take the events dot relative dot x. Relative is the variable you use when your mouse is captured. It gets essentially the amount of rotation from the previous, the amount of rotation, or not the amount of, the amount of mouse movement since the last time the variable was checked. So we're going to get the x component of that. We're going to do degrees to radians. This isn't really in degrees, but the rotation variable is in radians. And if we don't do this, this number is going to be so big that it's just going to make the camera spaz out. So we do this to kind of bring it down to a sensible speed, and we multiply by mouse sensitivity, which is the variable we defined up here. And notice we're taking the event relative x, but we are editing the y component of the rotation. And I want to see if, all right, we can't see the whiteboard from this, so I'm gonna roll it over. But the reason we kind of have these swapped around is because are there markers here? Thank you. All right. Bring this over so the camera can see it. So if we have, and ignore the fact that the board is shining on this, but if we have our player, let's say this cube is our player, we can imagine the screen as kind of a plane in front of them, where this is your horizontal movement or your mouse movement, and this is the vertical mouse movement, right? So if we have a movement on the x-axis here, we want the player to rotate like this, right? And that's going to be centered on the vertical axis, on the y-axis. That's why when we take the horizontal component, we need to change the y-axis because that's what it's rotating around. Yep. And then for the vertical axis, the y-axis, we want to rotate around the x-axis to look up or down. Does that make sense as to why we're switching that? All right. So back to Godot, we're going to set the rotation, or we're going to change the rotation dot y by the amount that we have moved the mouse. We're also calling this wrapf function. So what wrapf does is it will take a value, take a lower and an upper bound. If it's past that upper bound, it's going to wind it back the other way. Think of it's kind of like the modulo operator, but instead of just being for integers, it's continuous. And the reason this can happen is the rotation around the y-axis or around any axis is stored in a floating point number. And the thing about floating point numbers is when they get really big, they lose precision. So if you're running around a level and you're, spinning around in one direction for a long time, that rotation number is going to get really big, and then it's going to start becoming choppy because you lose precision. Now, you would have to do it a lot to get to this point, but I figured I might as well mention it. So we're going to do the same thing to rotation.x with event relative y. And then instead of wrapping this, we're going to clamp the rotation.x because you shouldn't be able to look up and then start looking backwards around your head. And same thing, you shouldn't be able to look down completely vertically and then start looking backwards around that. And then we'll just check if it's not a mouse motion, then we can check against the zoom in and zoom out events, change the spring length. Notice that this is named similar to the spring length here. This is the same variable. When they defined this in Godot, you can do a thing where you can define a variable and it will automatically appear in the editor. And it's a standard name too. So it will turn underscores into spaces, and the first letter of each word, it will make it capital. So spring length here turns into spring length here. I could also access the shape. I could also access the margin, all that stuff. But right now we just need spring length. So if we zoom in, then we decrease the length to get closer. If we zoom out, we increase it. And then we're going to clamp that to the minimum and maximum. And if we run that, now we have a camera that we can move around, and notice that when I run into the wall here, instead of clipping through, it will collide against it. That's why we have the spring arms. So when we're running around and the camera hits terrain, it's going to just glide against it instead of clipping inside. Same thing for the floor here. Now, for the floor, if it's at a really sharp angle, it will just go through. That's one of the reasons we have clamp, because if we didn't, I could just, let me show you. If we comment this line, run this, it's going to try its best to run along it until we get too steep that it clips through over the other way. And now the camera's upside down. So that's why we put that clamp there. So now that we have our camera set up, let's add the script for the player. So we're going to go back to the workshop book, 10.2, and it's going to be all the way at the bottom. Also, if you try and follow along with this, you'll notice that it's not finished. I will get that done this weekend, but for now, this has most of the code we need, and the remaining code will take like 10 minutes to make. So copy that. We're going to right-click the player this time, attach a script, player.gd, and we're gonna paste that in. Now, I know you probably want to hit play right now just to see what it does, but give me a moment to walk through this. So the first thing we're doing is defining a type. An enum is essentially an option between several states. So for this player state, if a variable is of a type player state, it can be either idle, running, jumping, or falling. Enums exist in most languages, including Java, Python, basically everything you'll use, but they're not very common. So this might be the first time you'll see one, but it's just an option between a handful of states. We have a couple constants. We have the player speed, the jump velocity, jump boost velocity. I'll get into that later, and the angular velocity. We have a couple of variables to keep track of state. These are for animations. I'll talk about that in a minute. We have the current state of the player, which will start at idle. We have the direction. This is related to the input. So we're going to have one function that reads from the input and sets this direction. And we're going to have another function related to physics that reads from the direction and applies it to the player movement. We have our gravity. And we also have, so this onReady annotation means that a variable won't be initialized until the node is until the node is loaded. Basically, this will run at the same time as the ready function itself. So the reason we're using onReady here is because we're actually referencing other nodes in this script, and these other nodes need to be initialized before we can access them. And you can either use a $sign, and you can either type out the path, or you can literally just, from wherever you are in whatever script you're in, you can just drag it in, and it just makes it for you. So you'll also need to use quotes if the path has a space in it. So we have the camera, a reference to the camera, a reference to the model, and a reference to the animation player in the model. Remember, the model here is it's a reference to the GLTF, and that just contains it's basically a scene itself, right? It just has the nodes for the different parts, it has the meshes, and it has the animation player. And I'm pretty sure if we demo it in here, yeah, the walking animation looks right. Going back to the script, we're going to have, trying to see if I can make this a little bigger.
show the animation.
You just, the scene over here, you're going to click on the little clapper, open anyway. Go back to the 3D view. Also, the tabs up here. This is important. This is your script editor. This is the 3D view. If you're seeing, this is the 2D view. You can have 2D and 3D stuff in the same scene at the same time. And the way that would work is the 3D stuff is going to render from the camera, and the 2D stuff is going to be like a HUD on top of that. So you could put like a health bar there, items, stuff like that. Or if you have a completely 2D game, you would make it in the 2D view. Or if you have a menu, it would be in the 2D view. We have game here that this will, if I uncheck this and I run it, don't worry about that. Then it will embed in here. I don't find that very useful, so I just make it a floating window. And the reason that error is popping up is because we have, and the reason that was popping up is because we had the scene open while we were running it. And it's not a real scene in our project. It's a reference to a model. So, that can just stay in there. And even if you do have this opened in another tab, it's not like the error will mean anything either way. Why does that? All right. So Alt F4 is closing the whole engine instead of just the game. So what I'm going to do is just add a little bit of code that takes escape and quits. So cancel. So I'm just going to add a new node here, create, move it to the top. And it's just going to do this. Couple lines, but what this does is on process will run every frame, and it'll just check if the escape key is pressed. If so, it'll quit the game. Save that, run it, and then when we want to get out, we can just hit escape. This isn't on the website, by the way. I just put this together now, so just copy it down. I'll give you a minute. Yes. What you can do is go here. Let's say we want to rotate the player. We can either use these circles to rotate it, or if you keep accidentally clicking the arrows or like handles or something, you can click up here to just get the rotation gizmo. This is all three: translation, rotation, scaling. Yeah. It was get tree dot quit. Are we all there? All right. So back to the player script. We have these references. Now on process, remember this is called every frame, not exactly every frame, but like 60 or so times per second, right? And it gives us this delta variable that is the amount of time that has passed since the last call. The reason we need this different computers are going to run this program at different speeds. So that means the process function will get called more or less often. So we can use this variable to normalize it and make sure the game doesn't actually, like the player doesn't move faster on a higher end computer. So the first thing we do is make a variable called input direction, and it's going to be a vector between these four actions we made earlier. And what input get vector will do is we define four kind of forces on an axis. We define negative x, positive x, negative, or wait. Oh yeah, negative y, positive y. The reason why forward is negative and backwards is positive is because in Godot, the y-axis is reversed. And we're also going to be mapping it to x and z because it's going to be on the floor, but that comes later. And the benefit to this is if we want to add controller support to the game later on, we can just add the joystick directions to these four things. And now this will actually produce like a strength based on how much you're pushing the joystick in either direction. And you just get that for free. You wouldn't have to program that in. Then we set our direction equal to transform.basis essentially gets the kind of orientation of the player. We're going to multiply it by a new vector that, does everyone here know what a vector is? Yes, Cosm? Oh, sorry. So what we're taking the x and the y components of the input direction, and we're applying it to the x and z components of the vector, because we're not actually going to move, the WASD is not going to move us vertically, so we don't want to actually edit that in 3D space. We're just going to set that to x and y here. We're going to normalize it, which makes its length 1. That means we could multiply it by a scale and have that be consistent. Then we're also going to rotate the direction based on the rotation of the camera. And I'll show you I'll show you what happens without this line. Then we have our input direction. We take the Y rotation and essentially we're taking how am I going to explain this? I think it would be better if I just show you how this works when it's not here, but I want to get through the whole script before we play it. So just keep this in the back of your minds. Then we're setting the player states. If not direction here, basically, if you treat a vector as a Boolean and you try and use like Boolean operations with it, the way it'll behave is if it's 0, 0, 0, it's false. If it's any other if it's a direction or if any of the numbers are not 0, it will be true. So this is essentially saying, is there an input direction right now? And is the player on the floor? This function comes with the character body 3D. So you can just check if the player's on the floor. You don't have to implement that yourself. We set the current state to idle. If there is a direction and the player's on the floor, then the player is running. And if neither of these are true, that means the player is not on the floor. So in this else block, we handle in air. If the velocity.y is greater than 0, that means the player is going up. That happened from a jump, so we set the player state to jumping. If it's not, then the player is falling, and we'll call update animation, which is defined at the bottom. Now we have physics process. This differs from the normal process function that this is called in fixed intervals. The normal process function is going to call whenever it's convenient, whenever it has enough resources to do so. But since physics needs to happen on a normal schedule, it is guaranteed regular slots over time. But the thing is, we don't want to put too much stuff in here, and we only want to keep it related to physics because we only have so much time in the scheduler. And if we put too much in the physics process, it will start to degrade the performance. So in the physics process, we check if we're on the floor. If not, then we'll apply gravity. Notice we're using delta here. That way, gravity applies at the same rate no matter how good the computer is. If we press jump and we're on the floor, then we set the velocity.y to the jump velocity. That creates an impulse. And if we release the jump and we're still rising, then we'll cut the jump short. And I'll show you exactly what it does later by showing what happens without it. If there is a player direction, then we'll set the velocity to that direction times the player speed. If not, we'll set it to 0. Move and slide is another function provided by the character body 3D class that will just take whatever velocity you set and put it in the physics engine. It'll move, it'll collide, do whatever it needs to do. Finally, we have our update animation function. It will just check the player state and play the appropriate animation. For jumping and falling, because you can jump and fall at different heights, you can't know how long that will take and time that with the animation. So what the play function does is if the animation you request is already playing, it does nothing. But if no animation is playing, it'll play that animation. So in the case of the jump animation, this is like a quarter second long. So as soon as we jump and we complete that animation, if we didn't do any checks, it would just keep looping, and then it would keep looping the falling animation all the way down. We have these variables here to check if we already played those animations during the jump or fall, so we don't play them again. And then we reset them when we're on the floor. With all that being said, if we run it, we can see the idle animation. If we jump, notice if I tap space, it's a short hop, and I can control the height of the jump by letting go of space at certain times. I have WASD, and I can also move the camera around. Now let's go through some of the parts of this script and remove them to see why we do things, to see why we have some of these lines. So the first thing we're going to comment is this line, and this orients the player based on the rotation of the camera. So if we have this gone, if I hold W, if I run around, this is going to be the same. Like I'm holding W, it's traveling in this direction, right? If I move the camera over here, it will still travel in the same direction. So we have this line to basically make the player always point towards the camera. Now, if I hold W and I make the camera look over here, it travels in that direction and everything's oriented correctly. Next, we have this here, and all I'm going to do to show what happens is I need to substitute this line with something slightly different. So if we just have this, notice it snaps really harshly to the directions. So what this is doing is atan 2. So you know how in trigonometry, and I'm going to pull the whiteboard over here. If we have a right triangle, who remembers learning SOHCAHTOA? So if we have an angle here, this is our hypotenuse, the opposite, and the adjacent. If we want to find an angle from, like, say we have a vector x direction and a y direction, this is basically the adjacent and opposite sides of a triangle. So you want to use tangent to find the angle for that. In this case, you want to use inverse tangent. The thing about the normal inverse tangent function is its range is from negative pi, and I hope I'm remembering this correctly, negative pi over 2 to pi over 2. So this whole half of the unit circle is not covered by the function. And this ends up producing wrong numbers, wrong values for this. So what game engines provide is the atan2 function, which stands for arc, tangent. I don't know why they put the two, just like a second one. Yes? That is actually, yeah, good point. You pass in two numbers to it. And this is essentially the tangent function, but it covers the whole unit circle. So you can work with all without worrying about, do I have to add 180? Do I have to subtract 180? Stuff like that. Are we on time? 4:33. All right, about 20 more minutes because I'll reserve the last 10 for questions. So we're setting the rotation dot y to just the angle of our direction, and that does it very sharply. If we remove this and bring this code back, lerp angle will essentially take an angle and another angle and smoothly transition it. So we're taking our current angle, we have the target angle, and angular velocity times delta is essentially the amount to move it by. Yes. Yeah, lerp angle, atan2, clamp, wrap, all that stuff. Anything purple is built into the language. And the reason we're only doing this is if there's an input direction, because if we don't, then every time we stop moving, the direction becomes zero and it's going to rotate back to zero. We want the player to stay in the direction that they were last moving. So we'll only edit it if there's an input direction. And then we have this here. Was there anything in here I'd say I'd remove to show you the difference in physics process? Nope. All right. So down here to checking so let's say we get rid of the checks for the jumping atom for if you already jumped. If we just go based off of the states, what's going to happen when we jump is it's going to keep looping the animations because once it ends, if I try and load up another animation, it'll just take it. So I need to have these checks in here. I need to have these variables keeping track of if I've already played the animation during the current jump or fall. Right, there was something here. Yes. If I remove this part, I cannot control the jump height. If I hold it down, it jumps that high. If I just tap it, it jumps the same height. What this is doing is if you release the jump action and your velocity is greater than zero, then we multiply this by 0.25 to decrease it a lot. And if we just have the first check when we release, we're actually able to slow the fall by letting go of jump after we start falling. And we don't want the player to be able to do that. So that's why we check if the velocity is greater than zero. Just release. So just pressed and just released. All right. So if back in the camera arm, if we have, or no, debug is better. Is key pressed? All this is going to do is if the key is held down, it's going to return true, right? What is action just pressed or just released going to do is if you hit it within a certain time frame, that's the only time frame when the function is going to return true. So if you're holding it down, this will be true for a split second, and then it will be false. So this is what you want to do for just sort of impulse actions where you only want it to happen when the player clicks the button and not while it's being held. All right. So we have the player, we have that. We have about 10 minutes to add the spikes and the oil can. So what we're going to do is make, all right, back over here. I'm going to bring this over a little bit. Map. we're going to make a area 3D. Under it, we're going to add, we're going to drag in the spike model. That doesn't matter. We're going to add a collision shape. And that's all that there is for a spike. And I'm going to rename this spike. We're going to set the collision shape to a box. And I moved the model. See, I made the mistake. I clicked on the spikes itself and it selected the model instead of the whole spike object. So what I'm going to do is go to transform, reset the position, and now click on the whole spike and bring that over. We're going to go to the collision shape, go orthographic, turn snap off, and that looks good. Maybe bring that down here. Yep. And I am pretty sure we have, yep, we can click snap object to floor and that'll just snap it right down to I clicked the model again. I need to click the full object and snap it to floor. So now let's add some logic to this because right now we can just walk through it. An area 3D is not a full collider. It will detect if something enters its area, but it won't actually block it. So what we're going to do is add some logic to this. Spike.gd is fine. And this is not on the write-up, but it's not too much code either. I'll give you a few minutes to put that in. Is everyone set? All right, I'm moving on. So the logic of this is pretty simple. When we collide with something, we're going to get the node that we collide with. If the name of that is the player, then so get tree, notice we also use this for debug. This essentially gets like the engine itself as an object. This allows us to close the application, load different scenes and stuff like that. So in the case of the spike, we're just going to reload the current scene. Basically, we're going to reset the scene, right? In the game jam, you might want to have like a fade out or some sort of effect happen when, on death, but it should be pretty clear how to implement that now that we're actually in this spot in the code. But notice if we run this, nothing happens. That's because this is not actually a Godot callback. If we go to the player and we go to, for example, physics process, we have this little blue icon here that shows us that this is a callback and will take us to the docs. So this is just a custom function I defined because there's no callback for when something collides with an area 3D. what we have to do for that is use what's called a signal. So if I choose the spike, another big feature of Godot is signals, where if a node can essentially emit an event like a radio signal, and anything that is tuned to listen to that signal will get that message. So what we can do is attach this body entered signal to this function. And notice the parameter here, body no 3D, this has to match the signal parameter to work. The name doesn't have to be the same, but the types do. So if I double click this, I'm going to scroll down. You can connect this to any script on any object, but I'm just going to choose the spike itself. I'm going to hit pick, and I'm going to choose it automatically detected that I have a function that matches the signature. So I'm going to hit OK, connect. Over here, we see that it connected to collision, and we see over here that this has a signal attached to it. So if we run the project, so let's move this out of the way so the player doesn't spawn in the spike. If we walk into the spike, we can see the scene resets. But notice we're getting errors down here. Why? Removing a... Come on, can I not scroll over? All right. Here's what I'll do. So this is basically the how much more space will cause that. All right. So this is the error we got. Removing a collision object node during a physics callback is not allowed and will cause undesired behavior. Remove with call deferred instead. Basically, this collision, because we linked it to the on the body entered signal, this gets emitted during the physics process stage of the game. So over here we have physics process. In Godot's code internally, this signal is emitted during here. And the thing about when the physics engine has its turn to operate on the worlds, it does not want any nodes added or removed during that time, because that just it's not built for that. When the physics engine has its turn, it wants the entire world to stay as it is. So you have to add or remove nodes outside of that. So when we are resetting, when we are reloading the scene, that effectively gets rid of all the nodes and triggers that error. Now, in reality, this isn't really a concern because we're already resetting the whole scene. So it's not like we're concerned with bad collision happening or something, but it's still good practice to not have the error. So what we can do instead is do call deferred. Reload current scene. And what call deferred does is it will wait until a function is safe to call before calling it. And if we do that, we can see that no more errors, right? So what we can actually do with this spike also is we can drag it into the file system and we can save it as its own scene. And this is similar to a prefab in Unity, where now you have this object that you can drag in as many times as you want, and it will just work, right? And if you want to change it, you only have to change this source scene, and it will reflect everywhere in your game world. So the final thing we're going to add, and I'm going to try and do this as fast as possible, is the motor oil can. All right, now we have that set up. We're going to attach a script. I'm going to rename this first. Also, when you attach a script on something with a default name, it's just going to take the name of that type. I would not recommend doing this because then you could accidentally put a script. Like if you make an Area 3D script, right? You could have a completely different object that's also of type Area 3D. And if you try and if you just quickly make it and hit create, it's going to go to the same script. So it's a really good idea to name your scripts something custom. I'm going to call this win. And I'm also going to rename the object to win. And I'm just going to throw this script together as fast as I can.
At some point, um, we'll find we should cover air general, but
All right. I will take. So since this is going to take a little longer, I'm probably going to have to move questions to at 5 o'clock. So I apologize if you're going to have to leave then, but I'm going to take the next 4 minutes to cover the oil can, and then I will talk about the game jam for the last five. So looking at the, why is this not doing anything? Oh, make that the callback. And now, yep. So we can have it. So I could have made this an animation in Blockbench and just exported it with a model. But some things you can also do in code, such as having it spin and bob up and down. And the way we do that is we just rotate Y with a speed times delta. And then we will also set the vertical position based on a sine function. The final thing we're going to do is go here, link this to the collision function. And what this does, instead of resetting the scene, it changes the scene to a variable called next level. And notice I have export here. And that makes it so it appears in the editor, just like we have, the material here and use collision, everything like that. That is how that appears in the editor using the export tag. So what I can do is I'll create a new scene. I'll call it test. And I'll just throw in this here. Save that. And now if we go to worlds, we can drag the test scene into this slot. And if we run into the motor oil, it changes to the scene. And I don't have the debug object in the scene, so I cannot hit escape. Oh, Alt F4 didn't close the whole thing. That's nice. F8. Would you look at that? So then we can drag this down here, save that as a prefab, and then we could bring it back up and put it under the, why is this not? Oh, wait, this is the script. What am I doing? Did I set this to this? Oh. And I could, if I, okay. So what I can do here is clear this. So this has, despite them coming from the same prefab, exported variables, all the properties here can be custom to each instance. So this one will have the test scene assigned. This one won't have a scene assigned. And I will just bring this up, over, and out. So the first one went to the test scene. The second one will just throw an error because we're trying to go to a scene that doesn't exist. That is all the content I had planned. There's also a copy of this project on the GitHub repo. You can get to that by the same link you got, assets.zip. And this is perfect timing to talk about the game jam. Simon, would you like to take the floor?
So, I'm curious, how many of you are signed up for the game jam? Are all of you hoping to attend the game jam? Last week we were doing a Linux and Git workshop, and those people weren't interested. But game developing, I assume. So if you are interested in signing up, you can do so here. It's a QR code. It'll take you form. There's one extra click. It'll take you to the home page. Should be a big register now item you can click on. But this will be the week after spring break. It's Friday, 21st and 22nd. There is the normal 24-hour competition. There's also a novice tier. We've tried a few versions of this over the last few years, trying to figure out what to provide to students to help them succeed, especially new students who aren't familiar with game dev. So if you're one of those students and be interested in receiving some more help, we have a novice tier that starts Saturday. Doesn't mean that you have to do anything Saturday. This is just when we'll have stuff available for you. It'll be available online. We'll make posts over the CPT Discord. And then throughout the week, we'll also have office hours, so some during common hour, maybe some later, depending on CPT's availability. And then we'll help work through whatever issues you're having with the game. So instead of only having 24 hours and you hit a bug and get stuck and then the time's up, you can spend a lot more time. You wouldn't need to spend all the time. Obviously, it's not a 128-hour competition. You don't need that. But you work on it on the evenings or whatever's convenient for you, and then ask questions to CPTs to help you get unstuck if you're on that. We're also planning to provide some assets so you don't need to learn Blender over the next week. If you try Blender, it's difficult. Do any of you have any questions about this? Would any of you like? I'll leave this on the table so that we walk past, we can scan the QR code and sign up. But that's all I have. So David, if you, are there any other questions for David?
Yeah, if there are any other questions about this, about Godot, anything, feel free to ask.
You guys think, learn anything?
All right. Well, in that case, thank you for attending and have a wonderful spring break.